they have a lot of failures in the hydraulic system. We eliminate the downtime because our systems last longer. We have Prognostics in our system. The belts that we use have steel rope on the inside. We're able to put electricity through those steel ropes, and we're able to measure the electrical properties of the steel. And we know that the belt is aging, and we can let the operators know that it's time to service the system before it fails. So customers know that something's going to break before it does, which is huge.
Good morning, good afternoon, or good evening, wherever you are in the world. Welcome to episode 137 of Resilient Supply Chain, Stories and Strategies that Keep Business Moving. I'm your host, Tom Raftery. This week's episode is a little different. I'm taking a couple of weeks off, so rather than leave the feed quiet, I wanted to share a conversation I published recently on my other podcast, Climate Confident. And I chose this particular episode quite deliberately because although the original conversation was about decarbonizing heavy machinery, it quickly became a discussion about something very familiar to anyone running supply chain or industrial operations: downtime, maintenance, efficiency, electrification, digital twins, and ultimately, autonomy. My guest is Hiten Sonpal, CEO of Rise Robotics, and one of the ideas I found particularly interesting is that the barrier to electrifying heavy equipment may not actually be the battery. It may be the inefficient machinery we're asking that battery to power. There's also a fascinating discussion later about why industrial AI may be getting ahead of itself, because before machines can be truly autonomous, they first need to become digital enough to generate the data AI needs. So I think there's plenty here for Resilient Supply Chain listeners. If you enjoyed the conversation, do check out and follow Climate Confident as well. I'll be back next Monday, the 24th of August, with Olaf van der Veen, and regular supply chain episodes resume on the 31st of August when my guest will be Asim Akram, CEO of Multisensor AI. For now, though, here's my conversation with Hiten Sonpal. Hiten, welcome to the podcast. Would you like to introduce yourself?
Sure. Thank you, Tom, for having me on the podcast. I'm the CEO of Rise Robotics. I've been a CEO of this company for about 2 years. Before that, I was CEO or president of a couple of other startups. And then before that, I spent a large portion of my career at iRobot Corporation, where teams that I led generated over $2 billion in revenues, shipped 9 million units across 20 products.
Nice. And let's talk about Rise Robotics. Who or what are Rise Robotics? What is it you guys are doing?
So Rise is a MIT-affiliated startup. 3 out of the 4 founders went to MIT, and the 4th founder went to the Rhode Island School of Design, which is also a well-known design school. And together, the 4 of them decided that they wanted to build exosuits. So think Iron Man, but without the jetpack. And in that process, they realized that they had to build systems to create linear motion and rotary motion. And they also figured out that hydraulics wasn't going to cut it for them, and that they needed to find something better. And so the team invented a new technology that we now call Beltdraulic. And Beltdraulic is exactly as it sounds. We've taken the oil out of hydraulics and replaced it with belts and pulleys. And in doing so, created a system that's 3 times as efficient, 3 times as fast, and 3 times as durable as hydraulics. And once the team had created that, they said, rather than invent the exosuit market, how about we tackle the existing hydraulics market, which is $750 billion a year? And so that's what we're doing now, is we're taking existing hydraulic systems and converting them to more efficient, more durable, and more productive Beltdraulic systems.
Okay. What's the problem with hydraulics? We've had hydraulics around in all kinds of machinery for, I don't want to say centuries, but certainly decades to almost centuries, I want to think.
Yeah, so hydraulics, you're absolutely right. Hydraulics has been the state of the art now for, call it 50 years, but now it's going to be Beltdraulic, and I'll explain why. So Beltdraulic technology was inspired by muscles. If you think about how our muscles work, there are fibers that are pulling to make joints move. And because of the pulling nature of the, call it actuation, we're able to move our limbs very fast. If you think of humans throwing a ball, so we're able to move our limbs very fast. We're able to move them very efficiently. We think about how little food we have to eat to operate the whole day, move around and do things. And these muscles last a lifetime. Now, yes, they're getting nutrients through blood and so on and so forth, but the core fibers essentially last a human lifetime, 70, 80 years. If I told you that I'm going to replace these muscles with the bladders that contain blood, and I'm going to inflate the bladders rather than pull, I'm going to push the joints open. And so my bicep would get replaced with a bladder that's filling up with blood, and my tricep would get replaced with another bladder that's filling up with blood. Every time I wanted to move my arm, I'd have to pump blood into this bladder. And if you just think about that process, it would be a lot slower because it takes time to get the liquid into the bladder. It would be a lot less efficient. You can imagine how much work the heart would have to do just to move the blood. And then it would be a lot less durable because the blood pressure would eventually lead to failure of that organ over time. And that's the problem with hydraulics, is that they're slow, they are inefficient, and of course, they're prone to leaking because there's pressure everywhere inside the system. And so every interface, whether it's seals or even more static interfaces, will eventually leak and need maintenance.
Okay, so if hydraulics are so inefficient, why are they still everywhere?
Because there hasn't existed an alternative for hydraulics at this time until we came along. And I'm glad you brought up the efficiency topic because one of the big trends that you're seeing these days is conversion of machines to electric, right? So electrification is happening in a big way. However, it's not happening very quickly in heavy machines. And that's because the hydraulic systems are very inefficient. They are roughly 25% efficient. So 3/4 of the energy that's put into a hydraulic system is typically wasted. And that means that if you take a existing diesel-driven heavy machine and you try to electrify it, you need a massive battery because so much of that power is going to get wasted. And that makes those systems unviable from a business perspective. California, for example, has an initiative to take its ports and make them zero emissions. And they want to do this by 2030. I think they'll have to extend the deadline some. But as part of this process, they put out a voucher program so companies could afford the more expensive electric systems. If you have a $400,000 forklift, electrifying it gets you something that's $800,000, right? So it's just very, very expensive. So California started this voucher program, but those vouchers get sold out in the first 2 weeks because they only have so much money for the program. And then the rest of the year, nobody wants to buy electric systems. And what we do is with our technology, which is 75% efficient, we cut the size of that battery down in half. So that $800,000 system is now closer to $600,000. So we make the systems more affordable. But it's not just the heavy machines that we make affordable. We also reduce the size of the charging infrastructure because you need half as much electricity at the charging stations. And then this whole process of electrification is going to take more energy transmission and generation. And we cut the amount of investment needed to increase those things by half because we don't need as much energy to electrify. So by making the nodes of this electrical network more efficient, we're able to reduce the stress on the entire network and reduce costs across the network.
And are your Beltdraulic systems just a simple drop-in replacement for the hydraulic systems that are there at the moment?
That's a great question. So in some products, the hydraulic system is completely exposed. So all four sides are accessible. And we're able to retrofit those systems, no problem. Just for context, our cylinders are roughly twice the diameter of hydraulic cylinders. So they do take up more space. In systems like an excavator, where the cylinder is exposed and has a wall or supporting material on one side, all we have to do is change the mounting point. So the tabs have to get re-welded. And then if you have a system where the hydraulic cylinder is buried deep inside the system, then we have to design the product around our cylinders. I'll add that any company that's electrifying already has to deal with bigger cylinders. So if you think about screw-type actuators, which are the alternative, and we're much better than them, and I can get into that later, those also have larger diameters for the same amount of force. So if anyone is electrifying in any capacity, they have to create additional room for the cylinders anyway. And so at that point, we would be a form, fit, and function replacement.
And I mean, you talked about it being belt-driven and it being a bit like a musculature that we have on mammalian bodies. In designing that, what problem took the longest to solve technically?
That's excellent. I don't think I've been asked this question before on a podcast, so it's fantastic. So part of it is like getting the density. So the key breakthrough for the team was when they started thinking about these fibers, they said, what can serve as one of these fibers? And they looked to other industries for inspiration. And they found out that the elevator industry had replaced steel ropes, steel cables with these belts. So that's where the innovation originally came from. And these belts have certain engineering constraints. You can't twist them and you can't put a fleet angle on them, right? So you can't twist them this way and then you can't twist them sideways. Because if you do, then the force and the stress becomes uneven, leading to premature failure. So what the team figured out is how to do the twisting and the bending in a way that would not lead to premature failure and how to package that into a form factor that could be easily applied.
And you're claiming faster, lighter, more efficient. You've also, on the website, you talk about quieter, lower maintenance. Usually engineering involves trade-offs. So what did you have to compromise on?
Yeah, so I already mentioned one of the compromises, which is that the cylinders have to be roughly twice the diameter. We think the diameter will go down and eventually be comparable to hydraulics. Right now, the belts use very contemporary materials. They use polyurethane and steel rope on the inside. But I can see longer term, those belts turning into carbon nanotubes or Kevlar. And so these exotic materials will actually help us increase the density, the force density that we get out of our cylinders. The second trade-off is because we have pulleys on the inside, they do take up some space. So the cylinders end up being a little longer for the same stroke length. And in some machines, that's a challenge, just like with the diameter, the dead length, if you will. The problem varies from machine to machine. In some machines, dead length is not an issue, and in other machines, it's very much an issue, and so it requires a machine redesign. But there are also machines in the middle where small changes in the mounting points can give you the additional stroke length that you need to install one of our cylinders.
And what would you say surprised customers most during pilots?
Most of our customers that are using hydraulic systems have used them for a while, and so they tend to be skeptical, and they actually need to see the technology working before they decide to implement it in their systems. So when they look at our systems, the thing that surprises most of them is how fast we can move and how precisely we can move, right? So because it's belt driven, these belts can run at very, very high speeds. And so getting to 2 meters a second of movement is just not a problem for us. And to do it precisely is also not a problem for us. That is a challenge using any other technology, whether it's hydraulic systems where trying to move liquid that fast runs into physical limits and creates tons of eddy currents and heat and even more wasted energy. Also creates safety hazards because the pressures have to be insanely high. And then if you use screw type actuators to run it that fast, the actuators experience what's called a screw whip, where the mass of the actuator, as you're trying to spin it that fast, ends up oscillating. And so it's not feasible to run them that fast. So the speed, which translates into productivity, which translates into greater revenue for our customers, is the piece that they find most surprising.
Hiten, most climate conversations ignore heavy machinery entirely. And the only time I've seen conversations around heavy machinery in the climate space is when we're talking, for example, about big diggers coming from the likes of Komatsu, who are going into the mining industry, and they're going electric to stop the use of diesel. But apart from that, you rarely see it. And China are moving the long-haul trucks, the 18-wheelers, to electric now. I think something like 50-something% of new 18-wheelers in China in December were electric. But for heavy machinery, it's hydraulics particularly is not something you hear talked about. Why?
Yeah, so when you think about energy in general, there are 3 areas to focus on. There is generation, there's distribution, and there's consumption. And folks look at those problems from what is relatively easy to do. So a new solar farm is relatively easy to bring up. A new wind farm is relatively easy to bring up. So those problems are getting a lot of attention because they are doable. Getting cars to electric is something that's had to start from an innovation perspective, right? And electric cars are still a lot more expensive. So it's not like most democracies can just mandate that top down. So there's a challenge in doing that. So they have to wait for customers to adopt it, and then they have to find ways to provide incentives to get customers to buy a more expensive product. And then when it gets down,
I'll I'll push back on that point, just because this year, for the first time in the European market at least, several of the EV models are now cheaper than their petrol and diesel equivalents.
well, that's exciting.
That crossover is starting to happen.
That's a piece of information I didn't have, because that's not the case yet in the United States. It might have to do with the supply chain and where the batteries are coming from and so on and so forth. So far in the United States, it's still been market pull, and then how can you incentivize customers to pull on that? And then when it comes to other gas engines, for example, like lawn equipment, because that would substantially increase the cost, there isn't really a ton of regulation around those. So in the US market, they are largely unregulated, and they do create a lot of pollution. And then when it's come to the heavy machines, there is this perception that it's going to be very expensive and vouchers are going to be needed and so on and so forth. So California is one of the few states that's doing that. There are a couple of other ports that are trying to clean up, because ports end up being very interesting property for developers. It's waterfront property, but it's also industrial and noisy and smoky. And if the noise could be brought down and the pollution could be brought down, then it would be a lot more interesting for developers to start to build high-end things there. So there's interest in ports in general. But I'll say that other areas of heavy industry aren't really looking at electrification the same way, and there isn't this legislative push to make it happen, because the problem is so distributed. There are so many manufacturers that all have to decide to commit to making this transition, and then they have to know that the market is ready to adopt it. And as I mentioned, currently, at least in California, it takes vouchers to get people to switch over to electric machines, because they are that much more expensive, because the batteries are that much larger.
And if I'm swapping out a hydraulic system for a Beltdraulic system, or if I'm trying to decide between the two, where are you there on the price point? And taking that a little further, we've seen, for example, in the battery space, in the wind turbine space, in the solar panel space, we've seen the costs dropping around 20% per every doubling of capacity installed. So that's standard Wright's law, learning curve, et cetera, et cetera. Where are you guys in that space?
Yeah, so at scale, we expect that the Beltdraulic system would cost 50% more than the hydraulic system. That's not the full product. And so let's call it a construction machine, the hydraulic system is about 30% of the total cost. And so imagine adding another 50% of that on. So we'd increase the full system price from a hydraulic to a Beltdraulic system. The cost would go up by 15%. That's if you didn't electrify it. If you just took the diesel engine and you turned it into a generator and connected that to our cylinders, which are electric. So that transition would essentially add 15% of cost at scale onto those machines. But then as I mentioned, the battery size could go down by half.
And in terms of the climate story, is the emissions opportunity here battery downsizing, reduced maintenance, reduced oil leaks, increased uptime, reduced energy use, life cycle economics, all of the above, something else entirely?
I think it's most of the above. You rattle out quite the list there. Certainly, eliminating diesel and moving to electric allows us to pick cleaner sources to generate the energy. So that's step number one. Second, reducing the amount of batteries that you have to put on these machines, or flip it around. You could put the same amount of batteries, use the same machines 2 shifts, and now you need half as many machines. And so those would reduce the amount of energy spent in mining and extracting materials and so on and so forth. Because I think electrification is going to happen anyway. The question is, can we do it in a way that's more efficient? Can we do it in a way that's faster and more economical sooner? Oh, and I want to add, you mentioned about leaks. Hydraulic oil leaks are really bad for the environment. Hydraulic oil is poisonous. It's a hazard. And so anytime there are leaks, really you need to remediate the soil and treat it. You just can't leave it there and let it run into the groundwater. However, because the leaks are distributed, it's very hard to catch those and make sure that they're clean. And so we have this hazardous element going into our environment despite best efforts. And so eliminating the need for hydraulic oil would solve that problem entirely.
And What's the business case then? Because if it's more expensive, 15% more expensive, as you mentioned there, what's the business case that gets operators to care? Because it's not going to be they want to save the planet. What's the business case there?
Yeah, so I'll talk about a couple of our customers, right? So one of our products is a liftgate, and liftgates go on the backs of trucks. You use them when you need to load something at a dock and need to deliver it at ground level. And the highest capacity commercial liftgates are called railgates, and they can move as much as 5,500 pounds at a time. And they have a lot of failures in the hydraulic system. So we eliminate the downtime because our systems last longer. One of the things I didn't mention earlier is that we have Prognostics in our system. Because the belts that we use have steel rope on the inside, we're able to put electricity through those steel ropes, and we're able to measure the electrical properties of the steel. And we know that the belt is aging, and we can let the operators know that it's time to service the system before it fails. But if you have a hydraulic system, you can't really tell when a hose is going to fail, when a valve is going to stop working, when there's going to be a big leak that causes the system to lose pressure and not operate normally. So we get the prognostic capability so customers know that something's going to break before it does, which is huge. For our first commercial customer that's just buying our cylinders, we found an OEM in the oil and gas space, and we're excited about cleaning up oil and gas production. We don't think it's going anywhere. So this particular customer builds natural gas pumps that capture the natural gas that's coming out from oil wells, and then they make sure that it's consumed as opposed to just being flared or being put into the air. And these natural gas pumps have hydraulic systems that foul up every 3 months. So every 3 months, they have to go service this. And our customer is based in Texas, and most of these wells are distributed all across Texas. So they have to send a crew out. And every time one of these systems fails and stops working, they lose roughly 3% of their output because they're running 24/7. So it imposes a cost on them. And they're able to go with our systems, they will have to replace the belts roughly every 9 months. And so we cut down the amount of cost it takes from a labor perspective to go service those. And we've converted them into things that don't leak and don't result in hazardous hydraulic oil that has to get disposed of.
And I'm glad you mentioned the prognostics, because I got to think hydraulic systems are mostly analog, right? You're not going to get any kind of information back from them. Is there more information that you can get back from the Beltdraulic systems? Can you get a lot? Can you give, I don't know, telematic information or some other kind of information back from the devices that gives the operators more value for their money, if you want?
Yeah, one of the key things we enable when a system is converted to Beltdraulics is we enable drive-by-wire, we enable teleoperation, and then we enable autonomy. So the drive-by-wire system is important because if you do want to make a system autonomous, you need to be driving it by computer. And computers typically need feedback so they know what the right position is. And we provide all of that out of the box. So our Beltdraulic cylinders have as interfaces power and CAN bus. We can certainly provide EtherCAT or any other interface that our customers want, but the typical offering is power and CAN bus. And through CAN bus, you can get the force on the actuator. You can get that by measuring the current that's being applied. You can get the position of the actuator, and you can also get the orientation. And so once you have those three things, you can create a very effective digital twin, which is a digital representation of the system. And having a digital twin allows teleoperation because now an operator can feel how the machine is behaving from a distance. They can have multiple screens and they can get a sense for what's happening. Otherwise, teleoperation is difficult because you really need to be in the machine to hear the whine of the pump, to understand how much you're stressing the hydraulic system when you're picking something. You need to get a sense of how the machine is moving to understand, is it going to tip, right? And those things are developed by intuition. But with our technology, because we're able to build a digital twin, we can build in policy that says, okay, you can't lift more than X amount in this bucket of this excavator and turn beyond a certain point so that you don't tip over the machine. So we can implement all of those safety features like anti-tip behavior at a reflex level so that when you eventually add autonomy to the system, you don't have to try and certify for those things. You can just focus on the top level operation. And teleoperation is key to getting to autonomous systems because most autonomous systems have this long tail. Waymo, which is this highly successful autonomous car company, which is a spin out of Google, also has teleoperators that help the system get unstuck when it doesn't know how to behave in complex situations, right? And they've been doing this for a long time. And so heavy machines, which work in an unstructured environment, will, even if they're autonomous, they're always going to need, I think, always, for the next foreseeable future, they're going to need a human operator to come in and step in and get the machine unstuck, because there will be these corner cases that can't be anticipated in training.
And do you think AI in heavy machinery is overhyped right now?
I think so. I think AI in general is overhyped. I think folks are talking because for a lot of technologies, there is an asymptotic curve of returns, and they're diminishing returns. And so even though people are like, oh, LLMs are 80% of the way there, well, that last 20% is actually a lot of work. And we got LLMs to this point because there was the availability of all this data on the internet, years and years of text that had been put in, but there isn't that much data for how an operator runs a heavy machine today. And so those machines would have to get first electrified, converted to drive-by-wire so you can collect the data. And then once you have the data, then you can start training the systems. And then you have to make sure that you can get through a large number of corner cases. All of that data collection has been happening in autonomous cars for some time. Like they've been collecting data and refining their models, and the Tesla Autopilot and the other autopilots keep getting better because every time they have a corner case, they code around that corner case, they run it through a test suite, right? All of that has to get done for heavy machines. So it's going to be a while, but we enable the first steps that have to be taken to make this transition happen. And what I see happening is not really replacement of humans, but amplification of humans. I see us going from people operating one machine at a time to maybe supervising 3 machines and getting them unstuck, and eventually working only on demand on certain jobs where there are certain things that can be done autonomously by systems. And I think that's going to take another 5 to 10 years before it happens. And I think fully autonomous systems, where I'm imagining where you go and scan a work site and then you put it in the computer and then you redesign the new, what it needs to look like in simulation, and then you hand that off to a set of machines, is probably 20 years out.
And your fundraising approach has been unconventional, if we want to put it that way. Why go community driven?
Yeah. So when I joined Rise, I found out that we had a community of 1,500 followers that were really excited about what we were doing. Some of them included suppliers that had come in and seen what we did when they're delivering something, and so they got excited. Others included folks from the MIT community. Others included robotics folks that had heard about Rise. And so we had this community of folks that had, in one way or another, asked us how they could get involved in participating in the upside of this business. And at the same time, when we were fundraising, VCs weren't offering really good terms. And so I saw an opportunity to connect the dots, and we took our last institutional round and we opened it up to the public via this regulation in the United States called Regulation Crowdfunding, which allows us to raise, after certain disclosures, allows us to raise up to $5 million in 12 months. And to my surprise, we ended up being the number one fundraise last year. We ended up getting almost $5.8 million worth of interest, which is 800,000 more than we could accept. And so we've had to open a second round to capture that interest and more interest that continues to come in.
Very nice. Okay. And if this transition succeeds, what do you think is going to happen to heavy machinery over the next 10 years?
I see them getting a lot cleaner, a lot quieter, more drive-by-wire, increasing the comfort level of the operators. I see operators being able to work from home sometimes, assuming that we can get into those machines and create a digital twin for them where they can experience exactly what the machine is experiencing. And then eventually, I expect to see incremental semi-autonomous behavior added on, where an operator, instead of working on every movement, can say, take that pile of gravel from X and move it to Y. And then they can supervise, and the machine, when it can't do something because the environment is too complicated, can stop and say, I need help. So that's what I expect to see happening in the next 5 to 10 years.
What sectors are going to change first? Ports, warehouses, mining, construction, agriculture, defense?
Yeah, so let's circle back to mining for instance. So mining is electrifying because the mines are getting deeper and they have to go further to get the ore that they need. And so it's getting expensive to put down the air shafts to provide air to the personnel and the diesel engines that are consuming a lot of the oxygen. And so electrification makes sense because it reduces their operational cost, and those shafts can be smaller to handle just personnel. And once they're electric, I think it's going to be easy, relatively easy for them to make them autonomous systems because they aren't necessarily colliding with other things in a mine, right? You understand that you're going down the shaft. It's a very well understood environment. So I think I see mining as being one of those first sectors that's going to transform. And then I think marine, we discussed, and it's not just ports, but it's also folks that own any kind of boat or yacht, really don't want hydraulic oil on their boat. And they certainly don't want hydraulic oil in a beautiful location that they've taken the yacht out to. The last thing they want to see is a trail of oil. And so there's a lot of pull from the marine space to go hydraulic free. Also, there are boats that catch fish and crab, and they have to keep them in tanks. And if you had a hydraulic oil leak and it gets into the tank, then the entire day's catch is ruined. So there are these pain points that need to get addressed relatively quickly. Food production and agriculture are another two sectors that I think will transform because folks want to get hydraulic oil just out of food and out of agriculture in general. So I think those are specific pain points that will cause electrification to happen there very quickly.
I want to go into a lightning round now where I ask you a couple of quick questions and you get one sentence to answer. Ready for that?
Yes.
Okay. What's the biggest hidden cost in heavy machinery today?
Lost revenue due to downtime.
Okay. Better batteries or better efficiency?
Better efficiency.
Okay. Most overhyped industrial AI claim?
That they're going to be humanoid robots inside warehouses replacing humans in the next 5 years.
Diesel survives longest in what sector?
Aviation.
Okay. Speed or durability? Which one?
Speed.
And lastly, what technology disappears first, hydraulics or combustion engines?
Combustion engines.
Okay, good. If listeners want to start electrifying heavy equipment operations now, having listened to this, where should they begin?
I would love for them to reach out to us. Our website is riserobotics.com. We have a contact form there. And if they could just talk about what they are looking to electrify, we'd love to have a conversation about how we can help them make that transition happen.
And a left field question for you now, Hiten. If you could have any person or character, alive or dead, real or fictional, as a champion for Beltdraulics, who would it be and why?
I think it would have to be Elon Musk because he has been pushing electrification. He has got a lot of companies that, like SpaceX, that use a lot of hydraulic systems. He's personally experienced problems in his cars because of hydraulics. I think the initial gull wing doors on their SUV had hydraulic systems, and then they had to replace them with something else because they just didn't work the first time around. So I think he could help us. Also happens to have a lot of money.
Great. Hiten, we're coming towards the end of the podcast now. Is there any question I didn't ask that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to be aware of?
It's a great question. Well, you didn't ask me about the stuff that's behind me. So this is our shop. It's a holiday today, so folks aren't working. But in our shop, you can see all of our products. Back there is the red cylinder there is capable of lifting 22 tons. And that cylinder is attached to a forklift test stand. It's also the cylinder that we shipped to a prototype that we built for the Air Force, which was the world's strongest robotic arm, which is used to load munitions onto planes. And then I'm trying to see if I can see a lift gate. So what you see there is a lift gate test stand where we test our lift gates. There is a banner there that says Guinness World Record for building the world's strongest robotic arm. And there are some test fixtures back there. Very back, the blue item there is a test fixture, which tests cylinders. And there's a bunch of stuff underneath here that is not visible. This here item is a collapsible crane. It replaced a product that the Air Force was using that weighed 1,800 pounds. And we replaced it with a system that weighs 300 pounds. And it's capable of lifting 150 pounds like the previous one. So we ended up saving them 1,500 pounds of weight, 1/6 the weight to do the same thing. And of course, it's a hand crank system like the original one, and takes 3 times less effort because we're 3 times as efficient. So that's a short list of products. We also have some other test fixtures here. And so you can see our lift gate there. And then down there, more test fixtures. So a lot of test fixtures in the lab. And then our work areas outside of the lab.
Okay. And was the Guinness record engineering validation or marketing strategy?
Both. So, and also the third reason was it was on my bucket list. So, shortly after I joined, the team told me, "Hey, we built the world's strongest robotic arm." And I said, "I don't believe that." And they said, "No, here, go take a look." And then they pointed to what was then the strongest robotic arm was a machine built by Fanuc, could lift 5,000 pounds. And we had built a system that could lift 7,000 pounds. And to be a robotic arm, you have to be drive by wire, and you have to have 6 axes of movement, which we did in our system. So you could do yaw, pitch, roll, and then front, back, left, right, up, down. So we had built that. So, and I said, if we've done something like this, we should get it out to the world. We should let the world know, especially because we had a crowdfunding round open, and we were also looking for customers who were skeptical that we could build something that was as strong as hydraulics. So both of those were important. So we went out there, and the process does require engineering validation. The Guinness World Records team asks the folks that apply to bring an external third party in to test the systems. They measured all the weights. They measured before we put them on the system, they put the right sensors in all the right places. We had to bring in a local policeman to make sure that the people who were testing were the people they claimed they were. So they had ID and all that stuff. And then we had to collect all the video evidence, and we had to send it over. That was the whole process. So very thorough.
Right.
And at the end of that, we got validation from an engineering perspective, certainly, that our tests that we had done were representative of the external company's tests as well. So it's really good.
Great. Hiten, that's been fascinating. If people would like to know more about yourself or any of the things we discussed on the podcast today, you mentioned the website already. Anywhere else people should go to find out more?
Yeah, they can contact me on LinkedIn if they would like to send me a direct link. And also, if they're interested in checking out our investment, they can go to invest.riserobotics.com, and we have our campaign page, and we talk about the opportunities. And also, there are other investors who've written investment memos that describe both the opportunity and the risks, so they can read about it and understand what's involved.
Superb. Hiten, that's been fascinating. Thanks a million for coming on the podcast today.
Thank you, Tom. This was amazing.